this is an implicit differentiation question. We have a function, f and g are constants, g is non-zero, and then we're asked to find an expression in terms of alpha and beta and f for the gradient of c at the point alpha, beta. So basically when x is alpha and y is equal to beta. Well, what we can do is we can take this expression here and we can differentiate it with respect to x, each term individually. So I'm going to get 2x plus 2y times dy by dx. Remember, you use the chain rule, you sort of differentiate with respect to y. Well, that's what you do, and then you times by dy by dx. I'm not going to go into detail on that. And then it's going to be the product rule on x, y. So if I differentiate x, I get 1, so I've got y. If I differentiate y, I get dy by dx. And that will equal 0, so the g has disappeared. Just need to tidy this up a bit. And now I'm going to factorize out that dy by dx. So it will be 2y plus fx. Meanwhile, I'll minus the other terms from both sides to get minus 2x minus fy. And then we can make dy by dx the subject. Maybe I take the minus out here as well, so it's going to be actually 2x plus fy all over 2y plus fx. And we're asked to remember for the gradient of c at the point alpha b, so at c, x is equal to alpha, y is equal to beta, and the gradient therefore equal minus 2 alpha plus f beta over 2 beta plus f alpha. In part B, we are told that f is less than 0 and f is not equal to 2, and the gradient at c is actually equal to 1. And we're asked to show that this is true. So it's worth just grabbing the key information that we have. So we can basically set this thing equal to 1, which must mean that 2 alpha plus f beta over 2 beta plus f alpha must equal minus 1 at c. So multiplied through, it's going to be 2 alpha plus f beta equals minus 2 beta minus f alpha. And we're interested in showing this is true. So kind of look at this for a second. We can see that we could write it as 2 alpha plus 2 beta equals it's going to equal minus f alpha minus f beta, or 2 alpha plus beta is equal to minus f alpha plus beta. Now, we were also told, remember, that f is not equal to minus 2. So alpha must equal minus beta. That is the only possibility. And we've essentially exhausted this. There's no other information we can get out of this question. But what we can do, remember, like it says, it has in the in our answer, we've actually got g back involved. So what we can do is take this original equation and substitute in. So therefore, at C, alpha beta, or equivalently, C alpha minus alpha, we've got alpha squared plus minus alpha all squared, which is also alpha squared. Then it's going to be minus f alpha squared, because alpha times minus alpha, that is going to equal g squared. And therefore, what can I write? I can write 2 alpha squared minus f alpha squared equals g squared. I can factorize out the alpha squared. So therefore, alpha is equal to, take the square root of g squared over 2 minus f. Remember, it's plus or minus. And alpha, if I take the square, I can take the square root of the top, which is going to be g, and then I'm left with this on the bottom. And then beta will equal minus plus, like it will sort of go with the opposite. Maybe it's a bit confusing to write that. So we already know that alpha is equal to minus beta, so I'll just add that on at the end. This is also where the condition f less than 2 comes in. This was stated at the start of the question. It's not absolutely essential to be using it, but if it was, for example, a 3, then you'd get a negative here in the square root. In the last part of this question, we are told that f is equal to minus 2, and we're asked to sketch C. Remember, this is our function, or equation, I should say, and we're asked to sketch that. So x squared plus y squared minus 2xy will equal g squared. We still don't know what g is, but we'll have to work in terms of that. And you've got to be able to identify this thing here. It's none, we need to factorize it. It's none other than x minus y squared. And that means if we take the square root, then x minus y is going to equal g, or x minus y is going to equal minus g. When you take the square root, you need to include a plus or minus. We only need to include a plus or minus on one side because otherwise you just, if they're both positive, it's the same as them both being negative. So you don't need to look at these extra possibilities. Or the left-hand side is positive, the right-hand side is negative. That's equivalent to the left-hand side being negative and the right-hand side positive. So we can write that y is going to equal x minus g, or y is going to equal x plus g. And in fact, our equation is just two straight lines. Right at the start of the question, we were also told that g is not equal to 0. So actually, we definitely will have two straight lines. It's only a sketch. I've made the gradient look like it's pretty much 1. Maybe I could have done a little bit better, actually. That's a bit better. So 1 here. And 1 here. We actually assume g is greater than 0. Then this one would be x minus g. And this one would be x plus g. Of course, if it's less than 0, it would just be the other way around. So nothing too much to worry about. This is minus g, and this is g. I think that's enough for our sketch. Okay, quite a nice last part to this question. Pretty cool curve.